Welcome back again to the first class of PySpark. Let's get started. If I ask you a question, what is big data? What would be your answer? Any volunteers? Mahesh, what is big data?
The data which could be which cannot be handled by a simple
Traditional.
traditional
Not
methods.
Gotcha. Wonderful. So, big data is a huge amount of structured, unstructured, semi-structured data, which cannot be stored and processed by traditional database management systems. So, what kind of a solution big data is offering?
Being able to process a large amount of data at a time.
Yes, but how? How is it approaching to process the large amount of data?
By storing them or using HDFS.
Okay, any thoughts, Priya, from your side? Mamata, any thoughts from your side? Come on, guys. Come on, start speaking. I mean, if you are quiet, then it doesn't make sense, right? Mamata, what do you think? How is it approaching? How is big data trying to solve the huge amount of data which cannot be stored and processed by the traditional database management systems? What is the central theme of the big data? Anyone? What is the central theme of the big data? As we have already
distributed
discussed.
storage and distributed processing.
Yes, distributed storage and distributed processing. So we resorted to distributed storage and distributed processing so that we can store more amount of data in commodity clusters and process that parallelly to process more amount of data in less time. Then is there any tool or component or any ecosystem to do that?
Hadoop ecosystem does that.
Awesome. Hadoop ecosystem. And what are the different components of the Hadoop ecosystem? Priya, which component stores the data in Hadoop ecosystem?
HDFS.
HDFS. Wonderful. So how does it store the data in HDFS? In what way?
In files.
In files. And is it distributed storage or not?
It is distributed storage.
It is distributed storage. So Mamata, do we store the data for the heck of it in HDFS to worship the data?
No, sir. For analysis, we store the data in the form of files.
For analysis, we don't store the data for worshipping or doing puja, like Dataya Namaha, Mangalaya Namaha, Udaya Namaha, Dataya Namaha, Hadoopaya Namaha. No, we are not trying to worship the data. We want to store the data so that we can process it. We can retrieve it at a later point and subject that for analysis. For that, we are storing the data. And how do you think we are processing the data in Hadoop ecosystem, Mahesh? Which component is helping there?
HDFS.
HDFS is for storage.
Is it Hive?
Hive, yes, Hive is indirectly processing the data. Do you guys remember the pasta story?
Yes.
Which component is related to the pasta story?
Data node and name node.
No. So what are the different components of Hadoop ecosystem? Which, if you what are the diagram which you have drawn? What are the different components of the Hadoop ecosystem?
Hive, yarn,
MapReduce.
MapReduce.
What is MapReduce? What is MapReduce?
Programming model.
It is used for
one at a time. One at a time. Okay. Yeah. Go ahead. Go ahead. Ayomide, go ahead.
Processes data.
Priya, please go ahead. Priya.
MapReduce is used for distributed processing.
Wonderful. MapReduce is a programming model for distributed processing because the data is stored in a distributed manner in HDFS, isn't it? We learned MapReduce is a programming model for distributed processing. And then why did we start using Hive? What is the necessary of Hive? Because MapReduce is already there. Anyone? Hari Babu, why do we need to have Hive?
To see in the form of tables, to retrieve the
correct. So
writing queries.
writing queries. What happened is MapReduce is allowing us to write the programs or code in Java. But most of the people who are associated with the data, they were not comfortable in Java as much as that of the Java geeks who created the MapReduce, who developed the MapReduce. That is when they thought of Hive. What is Hive, by the way, Mahesh?
Hive is an interface where we access the data.
Okay. Hive is a open source data warehouse which will help us in analytical processing, right? It will process the data which is there in the HDFS via MapReduce. And it is very, very easy because we can start writing the high QL queries, which are similar to the SQL queries, and process the data in HDFS via MapReduce. Means when you write a high QL queries and process the data, high QL queries are converted into MapReduce jobs that will hit the data in HDFS and processing happens and the results are relayed back to the Hive. Fine, fair enough, right? This is what we have been discussing so far.
Yes, ma'am.
Right. So we have HDFS, we have MapReduce, we have Hive. Why do we need Spark now? Why do we need Spark? We already have MapReduce for distributed processing. We already have Hive, which will help us in distributed processing through MapReduce. Why do we need a Spark when we already have important components which will help us to do the distributed processing? Any answers here? Why do we need Spark when we already have a wonderful MapReduce?
Maybe MapReduce only supports Java, not, but maybe Spark will support any other language.
So
Awesome.
no NoSQL also support MapReduce Spark.
Okay. Okay. Any other thoughts? So one of the thought from Priya is like, hey, I think MapReduce supports only Java. Maybe Spark supports some other languages. That is a good point. Any other thoughts from anyone? Come on, poke your brain. Why do you require Spark when we already have a MapReduce, when we already have a Hive?
Accessing data would be easier with Spark.
Why do you think so?
Because it supports other languages which can help it to access the data. For example, Python or any other language.
You can say process the data instead of saying access. Saying
Okay.
process the data. Okay, wonderful. That also is one valid point. Any other points? Any other thoughts from anyone? Come on, think. Ayomide. Any other thoughts? Why do we need Spark when we already have a MapReduce and Hive in Hadoop ecosystem? Okay, let us discuss that now. What happened is when the whole thing about the big data started somewhere in 2010, 11, like that. For some 4 to 5 years, MapReduce was the de facto programming model for distributed processing. Okay. Over a period of time, people started realizing, hey, I think MapReduce also has some shortcomings. What do I mean by that, Ayomide?
You mean it has some issues, like it doesn't.
Shortcomings means maybe it is not as robust as we think. Right? The people start realizing that. Okay. That is one of the main reason Spark came into existence. Okay, the people were, oh, okay, MapReduce, yes, it is wonderful. It did the job, but I see some negativities. I see some shortcomings, right? That is what we people realized, right? Let us understand those shortcomings. Okay, so when it comes to MapReduce, how does MapReduce approach the data analysis? Anyone? How does MapReduce approach the data analysis? Through map and reduce based computations. Means any data analysis task, we need to think or visualize them as a key value pairs, right? And in map and reduced based computations. Okay, in map and reduce based computations. Okay, so any doubts here? Any doubts from anyone? When you have to analyze in MapReduce, everything need to be visualized in key value pairs. See, if you recollect the way we did the analysis of the word count, we thought, okay, I need to come out with the mapper logic where the key is word, the value is how many times word is repeated. And reducer logic is we have to do a summation of all the values with the same key, right? With the same key. That is what we understood, right? Isn't it, Mahesh and Mamata?
Yes, Mahantha.
But the problem is we'll not be able to visualize all the database computations in a key value phase or in a map phase and reduce phase. What happens there is, like, let us say a filter. Okay, we want to do a filter. What is filter? What is filter? Priya? Your voice is very low. What is filter?
Removing or rearranging.
What is it? Can we bit louder, please, Priya? I'm hardly able to hear you.
To get specified result, we apply some condition.
So filter means we are filtering, okay, based on specific condition, as you rightly said. So if I have to think of filter, we have to have filter, then what we need to do is, okay, how do I visualize that in a key value pair? So sometimes very intuitive, simple things need to be thought through as a map and reduce based computation. It is not always easy to think in map reduce based computations. Okay, that is one of the important shortcomings of MapReduce. Then one more very important aspect here is MapReduce relies on reading the data from HDFS disk. What exactly does that mean, Mahesh?
I mean, the processing actually happens on HDFS.
HDFS. Okay, I mean, whether it is a Spark or this one, at the end of the day, the data storage is always in HDFS. So what it means is, assuming that you have multiple steps in your data analysis process. Okay, the idea is here you have a data in a disk. Okay, which color is it, Priya? The disk?
Gold color.
Gold color. Okay, golden color. Okay, we already discussed about this. So the data is there in the disk. In order to analyze this data and get the final results, we have couple of steps. One is step 1 and step 2. First, what happens is data is read. Data is read from disk. Then, as a part of the step 1 or iteration 1, some processing is done. So what happens here is, in order to get the final results, both the steps need to happen. One is step 1 and step 2. So after step 1, whatever the data processing is done, intermediate results will be produced. Right? Those intermediate results are returned to disk. And then when the step 2 comes, the intermediate results are read from the disk and the processing happens. Then final results are returned to disk. This is how it happens. What is the problem here, Ayomide? Why is it a problem? Why is it a shortcoming? Why is it a problem? Why is it a shortcoming?
Because it only stores stuff in HDFS.
Can you be a bit louder, please?
Because it only stores things in HDFS.
See, at the end of the day, HDFS is anyway, whether, as I said, whether it is a Spark or MapReduce, the data is stored in HDFS. Any thought, Mahesh, here? Why is it a problem?
Because numerous read and write requests will be happening. So
Bingo. Yes, you are absolutely right. So if you really see, the intermediate results are returned to the disk, and again they're read from the disk, right? They're returned to the disk, they're read. Are we processing only a small amount of data in KBs in big data, Mamata?
No, sir.
What is the amount of data we are processing? It is GBs and TBs and zettabytes and all those things, right?
Yes.
So what happens is, when we are trying to process the data in a large amount and it has multiple steps, in each of the steps, if the MapReduce is writing and reading, it takes a lot of time. It takes a lot of time. Are you able to visualize it, Priya? It takes a lot of time, isn't it, Priya? What do you say?
Yes, I agree with
Is it making sense?
you. Yeah,
Your voice is very low, Priya.
my energy is low today. So.
Okay, yes, your voice is very low.
Now can you hear me?
Yes, I can hear you. Okay. Is it making sense?
Yeah.
Yeah. Okay. Is it a reluctant yeah? Or
Yes.
yes, really yeah?
Really, yeah.
Really yeah. Wonderful. So that is one of the shortcoming. Okay. Then we do have a native support for the Java only. As Priya already indicated, there is a native support for the Java only. Okay, makes sense. Why is it a shortcoming if it is only Java? What is the problem? Why is it a problem?
It is not user-friendly language.
Java is not user-friendly language. All the Java guys will beat you, Priya. They'll say, what, Priya? Why is it a... No, we know Java.
Comparatively Python.
Now we are becoming clever. Okay. Yes. As Priya is saying, MapReduce is supported by only Java. As Priya rightly said, Java is bit more complex as compared to the other programming languages like Python. Especially the people who are associated with the data for a very long time, what is happening is they are more exposed to the SQL. They are more exposed to the SQL, which is pretty easy as compared to any of the programming languages. Okay, so the idea here is the guys who are working with the data for a very long time, they are proficient in SQL. That is relatively easy. All of a sudden, if you want them to pick up the Java, that is not going to happen. That is the reason it is a shortcoming. I hope you got it, right?
Yes.
So all of a sudden we tell you to learn Java. Is it possible for you? No, right? You find SQL is much better. SQL is easy. Okay, or I want to prefer Python rather than Java. That is one of the shortcoming. Okay. And one more very, very important aspect is it doesn't have a interactive shell. What exactly is interactive shell, Mamata? Mamata, what is interactive shell? Come on, guys, please unmute and start speaking. I don't want you guys to just be kind of a silence. It is we are learning a PySpark. Let us have some Spark. Come on. What is interactive shell?
Sir, like Hive, the Spark is not using MapReduce.
Not
I think.
we are talking about a shortcoming of a MapReduce here.
No, sir. Hive is interactivity.
Like that
like
we
that,
don't have.
Yes.
The MapReduce do not have an interactive shell.
No,
Spark
sir.
has it, ma'am. Spark has it. MapReduce do not have a. See, we are discussing why Spark. Spark
Sir.
came into existence because there is a shortcoming of the MapReduce. Okay, the not having interactive shell is a problem for the MapReduce. MapReduce do not have an interactive shell. Okay, makes sense. The next one is MapReduce do not have a support for streaming. Why is it so important these days, Chandrasekhar? Why is it so important to have a streaming these days?
Real-time data processing is important nowadays because, like for example, Zomato, for Rapido, all these things are using real-time data. So
Absolutely. So what is happening here is people want everything to be very fast these days. They don't want to wait for store the data for 1 month, then start analyzing. Right? Real time means the data is being created and analysis is happening. So unfortunately, MapReduce do not support the real-time streaming. So all these are the important shortcomings of MapReduce that led to the emergence of Spark. Make sense? Any questions here? So if you go back, what and all if we discussed at the high level, we are discussing why the Spark came into existence when we already have a MapReduce, when we already have a Hive, isn't it? So that is because MapReduce is one of the de facto programming model for the distributed processing for some 4 to 5 years since the inception of the big data processing was having some shortcomings. The people realized it and they started looking at what are the shortcomings, okay, then they found MapReduce does only MapReduce based computations and it relies on reading the data from HDFS disk and it has a support for only Java and it also have only interactive shell. It has interactive shell, it doesn't have interactive shell. It doesn't have interactive shell, okay, and there is no support for streaming. Fair enough. Any questions here from anyone?
No, ma'am.
Okay.
So that means the real-time projects is not using MapReduce. That the last point means.
Nowadays, yes. But earlier implementations obviously had MapReduce because then Spark was not there. You got it, right, Priya?
Yeah.
Okay, wonderful.
Okay.
Then we understood what are the MapReduce shortcomings. Now let us move on and see what is there in Sure. Are you guys enjoying it? Is it good? Do you have a Spark to learn Spark now? Is it better than Hive and all those things? Are Mahantha, start teaching. Why are you doing all this? Okay. Now let us understand what are the advantages of Spark. So now if I ask you a question, Priya, what are the advantages of the Spark?
It has an interactive shell.
Why did you say that? How come you say that?
Opposite.
Absolutely. Bingo. You are absolutely right. You're absolutely right. I like that. Okay. Yes. What else? What else? Let us ask someone else. Priya already understood the tactics here. Okay. Let me not ask any further question to Priya, at least in this slide. Okay. Mahesh, what are the advantages of the Spark?
So the streaming will be possible with.
Wonderful. Very good. Yes. Ayomide, can you bring up something from your like the bag? of answers.
It isn't only native to Java.
It isn't. It isn't.
Uh-huh.
That is what you meant to say? Yes.
Yeah, it isn't.
Bingo. Very good. Yeah, I mean, why do I need to teach here? You guys are getting all the answers. Chandrasekhar, any other thought from your side? What are the advantages of the Spark? Priya, at least pull some more.
Yeah, Mahantha, can you hear me now?
I can hear
Doesn't
you.
have to be relied on
it's-
HDFS.
Okay. Can you just paraphrase that properly, Priya?
So Spark doesn't have to rely on HDFS to process the data.
No.
Hmm?
Disk. See what? That is the reason
Disk.
I told the in MapReduce it relies on writing and reading from a disk. Okay. So you want to say opposite to that. What is the opposite of that?
You take less time to read and write.
Okay. And why is that, Chandrasekhar? Why is that?
Yeah, Mahantha. So because MapReduce is reading writing only in the disk. There is a disadvantages of the MapReduce, right? So Spark is using the in-memory processing. That's the main
Okay, there comes one answer. Wonderful, Chandrasekhar. Okay. So looks like your daughter or son is also learning big data. Is it daughter or
yes.
daughter or a son?
Daughter.
Okay. How old is she?
Yeah. Now 1.5 year.
Oh, she will be a very good big data developer. Okay. Wonderful.
Mahantha.
As Priya rightly indicated, whatever the shortcomings of the MapReduce, try to make it opposite of that. That will become an advantage of the Spark. One of the important aspect is Spark has an expressive programming. What exactly does that mean, Ayomide? What exactly expressive programming means?
You can express yourself. Well, I don't know. You can express yourself.
Okay. Am I expressive enough?
Yeah. Well, let me rephrase that. You don't have to follow certain rules, I guess. You can just, it's easier to.
Correct. You are absolutely
Yeah.
right. Which chocolate you want? You want Hershey's. I know Hershey's.
Yeah.
I remember. Okay. I'm going to remember that for a lifetime. Whenever, I don't know when we'll meet, I'll give you the chocolate. Okay.
Okay.
So I think almost Ayomide is there. So whenever I start talking, mostly people say I'm expressive. Means people need not struggle to understand what I'm trying to say. Am I right, Mahesh? More or less, I'm expressive. It is easy for when I start speaking, it is easy for the others to understand what I'm speaking.
Yes.
Right? So when programming is expressive, it is easy to understand and easy to work. Now, in terms of MapReduce, everything need to be visualized in a map and reduce based computations, key and value pairs. That becomes a difficult. So what Spark has more than 20 highly efficient operations. Okay, when you want to do a filter, you need not think the filter in a map phase and reduce phase. Filter is a filter in Spark. I hope you guys are getting it now. Okay, if you want to do filter in filtering of any data in MapReduce, have to think what should be the logic of a mapper, what should be the logic of a reducer. Nothing doing in Spark. It is just a filter. Filter the data frame and based on some condition. So Priya is thinking about a filter coffee. Right, Priya? Are you thinking of a filter coffee?
No, I don't like.
You don't like
I don't
filter
like
coffee.
coffee only.
You don't like coffee. What do you like, Priya, then?
Tea.
Tea. You are a tea person.
Yeah.
You are a tea person. You're not a coffee person. So who is thinking of a filter coffee? Mamata, you are thinking of a filter coffee?
No, sir.
No, you are also a tea person, or you don't drink
Yes.
anything.
No, sir. Tea.
Tea, okay. What? How come? Usually girls are coffee person. How am I yourself?
I'm a coffee person.
Okay, there I find mostly this is a common trend. I mean, I'm not saying 100% of the girls are coffee, but mostly I have seen most of the girls are like coffee than tea. Most of the guys like tea than coffee. I don't know. This is what in terms of the people whom I have met. Let us do some sampling here. Hari Babu, do you like coffee or tea?
Both.
Huh? Chandrasekhar, yourself, Chandrasekhar.
Myself, coffee, man.
Coffee. Okay. This is just opposite. Okay. Mahesh.
Both.
Both. Just you can be very clear. I mean, just because I said all the guys like tea, you need not be diplomatic. Coffee or tea? One. Choose one.
Coffee if it is good.
Coffee. Okay. Wonderful. So, Satish, yourself, Satish.
Tea, Mahantha, actually. If I get a
Okay.
coffee, I'll get a headache.
Oh, okay. Wonderful. So I think at least in this group, whatever the knowledge I have and what are the perception I have, girls like coffee and boys like tea, that is kind of opposite here in this group. Okay, so it happens. Or maybe my whomever the people I have met, and that is not a right sampling. Okay, coming back to our Spark. Spark is an expressive programming language, and we have more than 20 highly efficient distributed operations, and we can pipeline those operations to perform the data analysis or data engineering. Okay, so let us say operation 1. Okay, operation 2. Are you guys thinking about a eye operation, liver operation? No, right? I hope you guys are not thinking about it. Satish, are you thinking about any other operations? So what is operation here, Priya? What am I talking about in operation?
Whichever the relevant is required in the programming. That
I mean, when I say analysis or some task, that is what I'm saying. Okay, so we can string together these operations to perform the analysis. Okay, you guys got it? Unlike MapReduce, Spark is a expressive programming. It has a expressive programming. Okay, it has more than some 20 efficient distributed operations, which we can string them together to perform some analysis or any data engineering task. That is one of the important advantages of the Spark. Okay. Next one is Spark does in-memory processing, as Chandrasekhar said. That means, Mahesh, MapReduce do not do the in-memory processing?
I mean, in-memory process will do the processing in the client system. So this will be a server operation. MapReduce will be a server operation.
Okay. So what happens is, if you look at any of the processing tasks, all of them would be done in the memory itself. Okay. But the way it is done in Spark is much more efficient than the way it is done in MapReduce. What exactly happens here, assuming that any data analysis task involves 2 steps, step 1 and step 2. Okay, and as usual, the data is there here, and the amount of data we are processing is more than some 100 GB. I'm just saying more than 100 GB, right? So first thing is reading the data from the disk, and after that, in the step 1, processing is done, and it creates the intermediate results, right? Intermediate results, right? So that will be stored in the memory. That will be stored in the memory. Rather than writing the intermediate results to the disk and reading from that, it will be stored in the memory itself. And as and when the step 2 need to be started, the intermediate results will be funneled into the step 2. I hope you guys are understanding. Ayomide, are you getting it?
Yeah.
Instead of writing it in the disk and reading from that, it will be stored in the memory. So whenever anything is there in the memory, it is always easy to do the processing. It avoids the disk write and disk read. Okay, that will make the processing faster, potentially 25 times more than the any other programming model. Okay, you guys are getting it, right? That is the reason Spark is called as the in-memory processing, where whenever you have to perform data analysis, which involves multiple steps, intermediate results are not written to the disk and not read from the disk. Rather, they are stored in the memory until the whole task is done, until the whole analysis is done. As and when the next step needs the intermediate results, they are directly funneled to the next step. That avoids the disk read and makes the processing faster. Does it make sense? Any questions here? Priya, Mamata, any questions here? Any questions here, Mamata?
No,
No? Okay. Is Spark is good or Spark is bad?
it's good, sir,
It's good. Why is it good?
because we can get to the result faster than the method.
Faster. Okay. Then that is one of the advantages of the Spark. Then, as we already discussed, Spark does the batch processing also. What is batch processing, Priya? What is batch processing? What is batch processing, Mahesh?
The data will be processed in small batches, which
Batch processing means already there is a lot of data which is already accumulated, like years of data, months of data that need to be processed, right? That is a batch processing. By Spark, we can perform the batch processing. And also it has a support for stream processing as well. As our Chandrasekhar was saying, okay, we are in an era where people need the results faster. So instead of waiting to store the data and then subject the data for processing, as and when the data is being generated, subject that for processing. That is a stream processing. And our Spark does the stream processing as well. Fair enough? Then it has a beautiful interactive shell. This is the way Mamta explained. The way we have a interactive shell for the Hive, we do have a wonderful interactive shell for the PySpark, where you can write the code and you can get the results immediately. It will be easy for you to run, understand, and code. Okay. Then one of the wonderful things what our Mahesh was indicating, it has API to support all the important languages like Scala, Java, Python, SQL, and R. It has support for all these important. If you want to write a code in Java, if you're a Java geek, okay, go ahead and write a code in Java. If you like Python, okay, go ahead and write a code by using Python. Okay, I'm in between Scala, which is a hybrid language. If I like Scala, go ahead and write a code in Scala. Start working in Scala with Spark. That is also one of the important aspect. Make sense? Any questions here? Any questions? Priya, you understood? Mahesh?
Yes, ma'am.
no.
Ayomide, any questions, Ayomide?
No.
Wonderful. So if there are no questions, we'll wrap up the class.